to the final part where we're going to talk about waste treatment and disposal. So I'll introduce you to the concept of what nuclear waste actually is, what are the methods that we use at the moment to dispose of it, and finally we'll just look at old facilities in terms of decommissioning. So what is nuclear waste in terms of a definition? Well, the International Atomic Energy Agency, the IAEA, has a set of waste classification systems that the world follows, and these were set out in 1994. And it essentially divides nuclear waste into three categories. At the low end of it, there's exempt waste. So this is a material that has been decontaminated down to a level below which it would be classed as non-radioactive. Now, of course, it's got zero radioactivity, because when we looked at background radiation, we see that nothing has zero radioactivity, but the radioactivity is low enough that it's no worse than anything that you might find in the natural environment. So it'd be ideal if we could decontaminate everything to become exempt waste, because we wouldn't have any additional regulations for its disposal compared to, say, normal waste from a commercial site. Then there's low and intermediate level waste. So these materials still contain enough radioactivity that they have to deal with in a special way. Whatever the country has a specific regulation on that, because we need to protect workers and the public and future generations from radioactive dose. And these could be short or extended periods of time depending on what the isotope is that we're looking at. And then the final category is the higher level waste. Now these contain very high levels of radiation, certainly enough to cause harm, and cause harm for a very long time because they have long-lived isotopes in there. And therefore the only proper way of dealing with these is to lock them away and make sure that anything doesn't get into the biosphere for a long time. If you remember the curve we were looking at in terms of spent fuel treatment, it may be hundreds of thousands of years in some cases for long-lived isotopes. Now, those are the international classifications. In the UK, the Department of Environment, Farming and Rural Affairs, DEFRA, is the government department that's responsible for things like discharges into the environment, and they have interpreted the IAEA regulations into specific UK requirements. So in the UK, exempt waste is defined as anything that contains less than 0.4 becquerels per gram. So it could be any isotope, but it's 0.4 becquerels per gram. If you remember, the becquerel was a 1 disintegration per second, and is a pretty low measure of radioactivity. So you can see exempt waste actually has very, very low levels of radiation in them. The next category is the very low level waste. It could be low volume or high volume. Really, that's a classification for low volume is stuff that might come out of a laboratory, for example, whereas high volume might come out of a decommissioning project, for example. It might be rubble from knocking down buildings. And you can see we're really looking at things like kilobecquerels per meter cubed or megabecquerels per ton there. So that sounds like a lot of radiation, but there is a lot of material there, so it's fairly dilute. And you can see that note 1 and note 2, there is some definitions there for certain isotopes. So you can see things like carbon-14 and tritium have been singled out specifically, and you can see they can be higher than the limit. And the reason for that is because these, if you're near the sea or you're discharging things into the environment, there's quite a lot of carbon-14 and tritium already there, and therefore you can accept a bigger discharge because relative to the environment it's only a small amount. So those types of waste tend to come from operations or decommissioning. Then we get to the lower level waste, and lower level waste usually comes from some form of processing plant. And you can see we're into the gigabecquerels. Now, when we look at what we might do with low level waste, we can see that there's actually some specific processes that we use and procedures we use to lock away that. And you can see we've also divided out alpha and beta gamma as different types of radiation that we need to deal with. And interestingly enough, you'll see that the alpha is lower And that represents the fact that, as I was saying in previous lectures or previous parts to this lecture, that alpha can be more damaging, especially if it gets into the environment or gets ingested or inhaled. We come to what our classification is in the UK for intermediate level waste. And intermediate level waste would come from perhaps decommissioning the process areas of fuel treatment plants or waste treatment plants, and also a stream from reprocessing of spent fuel, which usually is the cladding. And you can see there's actually no activity limits there, because it's going to be treated in a very similar way to high level waste. The main thing is for long-lived alpha, and really that's just a badge for actinides. So things like plutonium, neptunium, americium, curium. So we don't really want a lot of those in the intermediate level waste, because of the way that we treat it is not suitable for those. And also heat generation, we want to keep relatively low. It's got to be less than 2 kilowatts per meter cubed, because we tend to treat intermediate level waste by using cementation, therefore we don't want to get too hot. Now the final category, there are no limits. High level waste can be any activity at all. It can be any heat limit. Essentially, there's no limits on that. So the final backstop for anything is it would be classed as high level waste. Now, the downside of that is that there's a lot of cost associated with high level waste. And as we see in subsequent lectures, we'll see what processes we have to use to lock away those particularly long-lived or nasty isotopes that we don't want to get into the biosphere. So in the UK, we've interpreted those DEFRA regulations and requirements into a policy, and we have 3 areas that we look at for waste disposal. So low-level waste, it goes to what's called the low-level waste repository at a place called Drigg, which is in the northwest of England, relatively near to Sellafield, and that takes what's classed as low-level waste and packages it up into these large containers here. That's an isofreight container, similar to what you might see on the back of a lorry, used for transport of goods, although in this case it's half height. And these half isofreight containers are stacked up into a large trench. Shallow trench burial is what's accepted for low-level waste, usually about 20 or 30 meters with clay lined, and then once that's full, it's covered over. And the intention is to lock it away for usually about 200, 300, 400 years. For ILW and high-level waste, so intermediate level waste and high level waste, we have different means of packaging them. So there's a intermediate level waste container. It's been simulated there, so it's been cut away to show the inside, which is cement. And what we would do is we'd put our waste into that container and backfill it with cement and seal the container, and that container is about 500 litres. Now we decided in the UK that we would dispose of those in a deep repository, and it'll be a co-repository because we'll do it at the same time as HLW. And the reason we've done that is decided if we're going to build one repository, it's easy enough for us, or better for us economically, to build a single one to take both ILW and HLW. Now, HLW, or high level waste, at the moment really only results from reprocessing, and it's the stream that contains all the fission products and some of those actinides that we're getting rid of. And that's changed into a waste form by a process called vitrification, where it's actually incorporated into a glass. And here's a picture of the glass containers. They're about 1.5 meters high and contain about 400 liters of glass. And these would be stored in an interim store to allow them to cool down, because they are quite hot from the radioactive decay. There's some storage of those intermediate level waste containers as well. Before going on to be treated and stored indefinitely in a deep repository, although the UK has not started to construct one of those yet because we're still looking for the right site. So I mentioned a few things there. I mentioned deep repositories and I mentioned shallow trench repositories. So what do I mean by that? Well, there's different ways we can deal with nuclear waste, and by we I mean the international community, not just the UK. There's deep disposal, which is the IAEA accepted standard for high level waste, and in most cases ILW as well, intermediate level waste. And that means locking it away underground, probably about up to many hundreds of meters, usually about 500 meters plus. And what we're trying to do there is lock it away for a very long time, away from the biosphere. We've got above ground disposal, which is a similar instance where we're trying to lock things away. In this case, we're not actually digging a hole. There's only really one example I know of that, and I'll just take you through that in a couple of slides later. And then there's also trench disposal or shallow disposal for the low level waste, which I showed you at Drigg. And finally, of course, there's free release. What we're aiming for there is to get it below that limit of 0.4 becquerels per gram as defined by DEFRA in the UK. And if we can do that, it means it's essentially not nuclear waste anymore. We can free release it to the environment as the terminology goes. That doesn't mean to say we're going to just release it into a river or the air or something like that. For example, it might actually be disposed of into a commercial landfill. So if we talk about deep repositories and deep disposal, we're talking about perhaps having something that's many, many hundreds of meters underground. There's a number of countries that have already started building or are in the final stages of building. In fact, Sweden and Finland have just opened or are very near to opening their deep repositories for spent fuel. In most cases, high-level waste in the world is spent fuel. And that has to be packaged up. It can't be disposed of directly. And here's a concept from the American Yucca Mountain repository. We can see there's some large containers there, and you just about see those square symbols there. They would be slots in this big steel container where the active spent fuel assemblies would be slotted in there. And then that would go into one of these tunnels. And this is an example of one being under construction. You see, it's essentially a mining operation. Above ground, you'd see some form of marshalling yard. This is an example of one that's in, I think it's Switzerland. And then here's a cutaway of the one that's in Sweden, where you'd have these tunnels where the waste would be driven down and then they'd be put into vaults. And there's a cutaway of the vault where the waste would be put into a borehole, and those access tunnels would be eventually backfilled, and everything would be backfilled once it's full, and it would be locked away. Now, the only above ground disposal concept that's been looked at around the world is a special case, and it's for the Chernobyl reactor. Essentially, at the moment, it's too difficult, or it's beyond our technological means to dismantle the reactor. The reactor building is so contaminated and it's in such a state that you can't actually work in there. It's just too difficult to get in there and strip it out, as we would see you would do under a normal situation for decommissioning a reactor. And therefore we've got to deal with that, and we've got to try and lock it away. They did build this temporary concrete sarcophagus, as it's referred to, over the building, just to make sure it's sealed away. That was done hastily, let's say. It was done, and it's not truly fit for purpose, and therefore the concept is to go underneath, build a large concrete essentially pad underneath it, and then surround it with this huge steel framed and concrete building that would be slotted over and moved over to the reactor to seal it away. Intention, probably seal it away for at least a couple of thousand years to allow quite a lot of those new shorter lived nuclides to die down, and then hopefully there'll be a technological solution in the future. So shallow or trench disposal is what we use in the UK, and it's what's used internationally for low level waste, and therefore it tends to deal with large volumes. So I mentioned the low level waste repository at Drigg. There's the picture of that handling equipment, and there's an aerial photo of one of those trenches. You can see there's the stacks of the isofreight containers as they're being put into position, and eventually when that's filled in terms of containers and waste containers, these trenches would be backfilled and sealed over. And here's an example of one in the US called WIPP, Waste Encapsulation Processing Plant, and again you can see the clay lined trenches there. There's some containers, in this case it's drums in the US, being put into position, and there's the process at the end when the trench is deemed to be filled, and they're backfilling it now and sealing it off. And again, we're dealing with relatively short-lived isotopes there. We want to lock that away from the environment for about 200-300 years, and therefore the clay and the material that's used to backfill it is essentially to stop or retard any water getting into the system while the radioactive waste decays. Waste disposal. The only other thing that we showed on our diagram was decommissioning. So what is decommissioning? Well, in the context of the nuclear industry, when we talk about decommissioning, we're talking about dismantling or removing from service a nuclear facility. That could be a whole reactor, of course, or a whole plant, such as a waste treatment plant. Or it could just be a large plant item. We may be decommissioning a piece of equipment. And the reason we do that, well, for one thing, we can't just leave things to decay away. Perhaps, there's many old buildings and things like that around the world that you see and around the UK that have just been left. They don't cause any hazard. There may be a chemotoxic hazard, of course, that may be, or a safety hazard. But in the case of radioactive facilities, we need to deal with that radioactive legacy that's been created by operating those. So we need to address that, and therefore we need to properly decommission. So in the regulation environment we have in the UK today, for example, you can't build something new until you've shown to our regulator that you have a decommissioning plan, or you know what you're going to do with it at the end of life, and define when the end of life will be as well. So we need to decommission properly our facilities so they don't become a danger to the public or future generations of the public as well. So if you think about all the different stages of decommissioning, we take that through. Let's assume we're talking about a reactor. So the first thing we need to do is decide to shut it down. So we're deciding now we don't want to generate electricity from it anymore. There could be many reasons for that. One could be economic, of course, or it may be it's reached its end of life naturally and it's time to decommission that, as in the case in the UK for all the Magnox reactors. Now the first stage is called POCO, P-O-C-O, or post-operational clean-out. That's a general term that's used for all facilities, but in the case of the reactor, the first thing we're going to do is take the fuel out. So we remove the primary source of radiation and hazard from there, which is a spent fuel, and that would go off for storage and then ultimate treatment, depending on what we want to do with it, whether or not that's going to be direct disposal or recycling. We could also flush through and remove the primary coolant, the water, and that would clean that out, and essentially we'd remove all the obvious radioactive components from that. Now at that point the reactor is still working. There's nothing that we've actually taken out of service there that means we couldn't put back in. So we could put coolant back in and we could put fuel back in, and we might decide to what's called mothball. Essentially that's a facility that's been shut down but is able to be reopened and reoperated. And there have been cases of reactors in the the US that were mothballed, and also in the UK there's been facilities. There was a fuel plant in the Sellafield site that was mothballed, although ultimately the decision was then to decommission it fully. So at that point, really, we've not really done anything to our facility that stops us from going back. Now the next stage, what we're going to do is actually go into decommissioning proper, and we're going to start to decontaminate. Now when we start to decontaminate, we may be looking at decontamination of the actual plant and equipment, in which case we might be using decontaminants, aggressive acids, things like that, to try and strip away surface contamination that's become locked in. Or we might be looking at decontaminating the building itself. We might have to take some of the surfaces of the concrete away. We've still got all the functioning equipment there, and therefore it goes into what's called service and maintenance. If we want to just hit the pause button, and quite often we hit pause buttons on decommissioning projects as we plan the next stage. So all the plant and equipment is still there, and all the safety systems are still functioning, and therefore the building itself still has quite a lot of manpower associated and operational costs. Now the next stage is we've decontaminated, we've got the levels of radiation down as low as we can. We can think about dismantling and dismantling of the plant and equipment. So we might dismantle, for example, things like the cranes or the fuel rods, fuel holders within the reactor pressure vessel, for example. We may even dismantle the reactor pressure vessel itself and the coolers and the heat exchangers and take those away for disposal. Once we've completed most of this dismantling exercise, we're left with primarily an empty shell for a building, although there may be some bits of equipment that's still in there that are still highly radioactive, and the building goes into what's called care and maintenance. It still needs to have some form of oversight because it still needs to be watched and looked after. The building itself needs to be maintained. There's still power, but essentially there's nothing there anymore. There's no plant. It doesn't look like a reactor. It doesn't look like a fuel recycling plant anymore. And quite a lot of our Magnox power stations are in this particular phase at the moment. All that remains is the building and the graphite core. Finally, when the decision is made, perhaps from economic or safety or just planning, we go into our final stage, and essentially what we do is we're going to start knocking the building down. And once we've completed this, there's nothing left. And it goes back to what's referred to as brown or green field, depending on the actual designation for the land usage afterwards. So you can see there's different stages there, and in each stage we can hit the pause button, we can mothball, we can just hold and go into a service and maintenance, or we can go into care and maintenance. And as we look at different facilities around the UK and around the world, actually, we can see this type of strategy being used.